So in this question here, we've got a ball is connected to a wall by a rope at an angle of 30 degrees, and the ball is pulled by a horizontal force which is of 35 newtons. So will be my forces diagram here. The 35 newtons going off in the easterly direction. This force here, which is the rope at 30 degrees, which will be pulling in the opposite direction, and then I've got my wall here. So one thing I can add in here, that this rope will be under tension by the weight of the ball and the 35 newtons force. So the tension in this rope will be going in the opposite direction as this ball here is in equilibrium. So that's the key point. So here we've got equilibrium. So it's not actually moving. So therefore, all the forces are going to be equal. So we need to calculate the tension in the rope and the mass of the ball. So first of all, I'm going to set up a triangle to represent my forces and the directions. So looking at part one, if I draw a triangle like this, then in this horizontal position, I will put my 35 newtons. Obviously got a right angle there. My vertical force coming down, that will be the weight acting on the ball. So here I've got my ball here, so that's mass times gravity. So this one here will be mg, and I've got my angle of 30 degrees. Now I don't have to use this angle here, I could use this one if I preferred as well. And then this line here on my triangle will represent the tension in the rope. So now I've got a good old-fashioned trigonometry puzzle where I can try and solve for either the mg or the t. Now first of all, what I could do is I can use SOHCAHTOA. So I could use sine of 30. So let's put sine of 30 degrees. That equals the opposite, which is 35 newtons, and that's divided by the hypotenuse, which is T for my tension. So that's a pretty straightforward equation to solve. Just the 35 is a value and sine of 30 is also a value. So let's just plug in my value for sine 30. So sine of 30 is a half, and that's 35 over T. So now what I can do is I can just divide both sides by a half and multiply both sides by t. So then I've got t equals 35 over half. Then I can multiply this 2 with my numerator. So therefore t equals 70 newtons. So that's the tension in the rope. So I can put that into my diagram. So t equals 70, and it's in newtons. That's the key bit. Now I need to find what's the weight of the ball. Now, first of all, I will need to find the force in newtons. So as my triangle here is all in newtons. So with that, I could use sine of 60 or I could use cosine of 30. So either way. So I'm going to use this cosine of 30. Let's do that. So for part 2, I've got cosine of 30. So that's just a value. Remember, that's adjacent over hypotenuse. So hypotenuse is 70 and adjacent is my mass times gravity. Okay, so now to find my mg, I just do 70 times cosine 30. Well, cosine of 30 is root 3 over 2. So let's just put that in there first. And then multiply both sides by 70. So then I've got 70 times root 3 over 2 is mass times gravity. So gravity is my gravitational constant. So in this case, with this question here, I'm going to use 9.81. Some questions will give you 9.8. Sometimes I'll use 10, try and make the question easier for the students to answer. So now I've got 70 over 2 is 35. So I got 35 root 3, got my mass, which are what I want to find, and then I've got my gravitational constant, which is 9.81. So if I divide both sides by that, I can divide by 9.81. Okay, so then if I do mass equals 35 root 3 divided by 9.81, I should get my mass. So mass should equal approximately 6.18. And that's going to be in kilograms. That's my standard metric unit when dealing with forces. So mass is 6.18 kilos. And that completes the question.